Hello, I am going to present my project on energy consumption forecasting and using a hybrid model of long short term memory networks, LSTM. So let's dive into the details. This project centers on developing a predictive model for short term energy consumption in households. With the rapid increase in household energy usage, there's a growing need for accurate predictions that can help consumers and utility companies alike. We've opted for a hybrid approach that integrates LSTM. These are particularly strong at identifying patterns, trends in energy data, which will help us in analyzing daily and seasonal usage trends, on further which we can optimize our electricity usage to conserve the resources. LSTM networks are tailored for time series data and can capture dependencies over time. Think of them as helping the model remember relevant information about past consumption patterns. By these combining approaches, we can aim to provide prediction accuracy and offer more meaningful insights into the energy sector. Now, why is energy forecasting important? Before we get into the technicalities, let us look at why this project matters. We are tackling a growing problem in the energy demand. First, with the rising population and urbanization, energy demand is skyrocketing, which can strain the supply, leading to shortages. Accurate and forecasting becomes essential for energy management. Utility providers can balance supply and demand better, reducing blackouts and improving reliability. From the consumer's perspective, effective forecasting translates to cost savings. Households can use these forecasts to adjust energy use during peak time usage or optimizing costs. From an environmental perspective as well, accurate forecasting supports the integration of renewable energy, lowering carbon emissions and carbon footprints of people and contributing to sustainability. Finally, as regulations around emissions and energy efficiency become stricter, forecasting models like these help meet regulatory standards. Now let's talk about the implementation process. So this forecast model that we have used, wherein we have collect data and worked upon that data, and to predict something from that data. This is basically data analysis processes, and we have used LSTM, where we have done time analysis and measured feature importance, and this is what our majorly energy consumption forecast model works upon. Now coming on to the implementation, uh, we have dealt with implementation in 5 stages. Data collection: we gathered historical data from a particular website on energy consumption, along with contextual features like time of day, day of week, weather conditions. These are some variable factors which helps the model understand influence energy usage. Second, it's data pre-processing. This involves cleaning the data, handling any missing values, and normalizing it to ensure consistency for effective training. This step is crucial as high quality data leads to better predictions. Then we move on to our model architecture. So this is basically the output that we received from the model, wherein we received distribution, voltage and count graph, and we received the global active power over time and global active power graph. These are dealt in time and energy usage. Coming on to the hybrid model architecture, it begins with a layer to capture some significant features which are passed on to the LSTM layer to capture temporal dependencies. This setup ends with a dense layer that generates the final predictions. The fourth stage is training and validation. We train our model and historical data, then validate on separate test sets to assess its accuracy and prevent overfitting. This ensures the model performs well on unseen data. Finally, deployment. The trained model is then integrated into an uh, application where users can see real-time energy consumption forecast and adjust their usage based on these predictions. Now, the once we should go back to the output of the code, wherein we are showing these two graphs, which helps us understand the patterns of consumption throughout the day across different time intervals, and as well as this lies over a period of years. And this also helps us to identify voltage patterns correlate with different consumption levels by people. This visualization actually helps us to assess model outputs, ensuring the predictions align with real world patterns and are practically useful. Now, this layer consists of a LSTM layer which handles the time dependencies, making sense of how past patterns relate to future consumptions. These are crucial for accurate forecasting as time dependencies heavily influence energy usage. The dense layer takes in the output from LSTM and gives us the predicted energy usage value. By combining these model training and this LSTM, we get efficiency as well as accuracy to our model. In conclusion, the project presents a unique approach to energy forecasting by using LSTM networks. Through this model, we can achieve more accurate, insightful predictions for household as well as industrial energy usage. This model has implications for utility companies looking to balance load, reduce costs, consumers aiming to cut down their bills, as well as to move more towards sustainability and environmental agencies focused on reducing emissions. Looking forward, the model could be further enhanced by integrating even more on real time sources such as live weather feeds or data from smart devices households. Additionally, improvements in computing power may allow us to scale this model even for large data sets. In conclusion, an accurate energy forecasting not only has technical benefits but also supports sustainability and helps us prepare for an energy efficient future. So, thank you.